Alright, this is a review of right triangle trigonometry. Alright, this would be a good preparation for an upcoming test involving tangent, sine, cosine, and maybe even little special triangle knowledge, 45, 45, 90, 30, 60, 90. So stay tuned. Please make sure that you can do every single one of these problems by yourself. Watch the video, but then after you've seen a couple, go back and do the problems on your own. Alright? Don't copy along with me because you won't learn anything that way. Let's get started. I guess I don't need to zoom in right now. So problem number 1. Solve each of the following right triangles. Round to the nearest tenth. That's 1 decimal place. Alright, other than the 90-degree angle, let's focus on the two pieces of information we're given. 55-degree angle and this side, this leg, length 9. Now, next we will look at whatever we're trying to find. So, let's say if we want to go after angle A. Alright, angle A is right here. So, well, I don't even need a trig function for that. Let's not be silly. You know that all of the angles in a triangle have to add up to 180. So this is already 90. That leaves 90 more degrees to be shared between these two angles. Okay? In other words, 55, angle A and B have to add up to 90. So, bottom line, if you want to find angle A, quickest thing to do is just to do 90 minus 55. Okay? 35. Kabam! 35 degrees. What's next? Side BC. Alright, BC is right here. Now, looking at this angle, 55 degrees, alright, this is the adjacent leg, and this leg over here is opposite. So I've got opposite and adjacent. That is the tangent function, opposite and adjacent. So let's use the tangent function. Pardon my yawn. So we will go tangent of 55 degrees is going to equal the opposite leg over the adjacent leg. So 9 over x. Alright, I taught you a shortcut for this. When you have the variable in the denominator, the quickest thing to do is to swap the denominator with this entire expression out here. Now don't just move the 55 and the x. Alright, you have to move the tangent 55 and the x. Okay, so bottom line, if I do that, then I will get the x will come over here, and over here I will have 9 over the tangent of 55 degrees. So I can simply put this in my calculator, 9 over tangent 55. Alright, 6.3. Okay, and remember, that was BC. So BC is 6.3. Now, how about AB? Okay, so let's erase that and start over. AB is this side right here. Alright, let me see if I can move this out of the way for a second. Okay, so for AB is this side right here. Again, from the perspective of the 55, 9 is opposite. But BA or AB is the hypotenuse. So we have opposite and hypotenuse. Which function is that? Well, the sine of an angle is opposite over hypotenuse. So we will work the sine function. Okay, so we will say that the sine of 55 degrees is equal to opposite over hypotenuse, so 9 over x. Okay, again, if the variable is in the denominator, what you want to do is reverse these. So we will have x is equal to 9 over sine 55. and you can put this in your calculator. 9 over sine 55. Okay, so 9 over sine 55. Okay, that's 10.98. So I need to round this up. So this 10.9 is going to round up to 11.0. Okay. So that's it for problem number 1. Let's move on. Oh, well, I take it back. That's it for problem number 1, part A. Let's move on to part B. Okay, let's find the measure of angle A first. Okay, so we are looking for this right here, angle A. Alright, now, how do we find angles, my friends? How do we find angles when we don't have any? Inverse trig functions, I hope I have trained you to say. Alright, when you don't have any angles and you're looking for the angle, you will need an inverse trig function. Get in the habit of using theta. This is theta, a circle with a line through it. It's a common variable that we use for angles. Now, so looking at this angle and looking at the two sides that were given, which trig function are we thinking about? Well, from the perspective of theta, angle A, this is opposite and this is adjacent. So opposite, adjacent. Which function is that? That's the tangent function. So let's rock the tangent. Okay, so we will say the tangent of theta is equal to opposite over adjacent, so 10 over 14. Now if you want the angle, you need the inverse trig function. So I will do the inverse tangent of 10 over 14. Now this can be put into the calculator. Okay, so I want the inverse tangent. Alright, let me make it so you can see this. So we will hit second tangent to make the inverse tangent. Now I forgot what we were doing. 10 over 14. So, you know what? Alright, 10 over 14. Alright, now we did the inverse tangent. So this is an angle. This is degrees. So 35.5 degrees. Okay, and that is angle A. Now, once you have one angle, there's no sense in doing an inverse trig function to find the other angle. Alright, I mean you can. We could do inverse tangent again the other way around. But usually what you want to do, once you know the one angle is 35.5 degrees, you know that these two angles are complementary. Alright, A plus B, they have to add up to 90. So the quickest way to find the other angle is to subtract from 90. So we can just do 90 minus 35.5, and that will give us angle B. Alright, that's 54.5. Okay, so that's what this is right here. Alright, and that's angle B. Alright, these two have to add up to 90. Now, side AB. Let's just slow down. Let's not forget about our old friend, the Pythagorean Theorem. You knew the Pythagorean Theorem before you ever started with this class. So don't you dare forget it. Okay, the Pythagorean Theorem, we often summarize it by saying a squared plus b squared equals c squared. But bottom line, that's what you're going to use anytime you're given two sides of a right triangle and you're looking for the third side. And this is no exception. Okay, so a squared plus b squared equals c squared. So we're talking about 10 squared plus 14 squared is equal to x squared. Alright, that's 100 plus, alright, I think this is 196 is equal to x squared. So this is 296 is equal to x squared. And then we will take the square root of both sides. Okay, normally we do plus or minus, but lengths cannot be negative. Okay, so square root of 296 is the bottom line. Okay, interesting. 2 radical 74, but we seem to be doing decimals, so we'll toggle that out. 17.2. Okay, so that is AB that we just solved for. Okay, and that is it for problem number 1, part B. Alright, here comes problem number 1, part C. And first we're looking for the measure of angle A. Well, we're given the measure of angle B. So angle A, I'm just going to do 90 minus 23. Alright, so that's going to be 67. Alright, so that's it. So angle A is 67 degrees. Okay, now I'm not actually going to use that for anything. Alright, for anything I need to find, I'm just going to stick to using the 23, just in case I made a mistake somehow. So if I want to find AC, alright, I'm going to put a variable on that. Now let's talk about it. From the perspective of the 23, I've got the 16, and now I'm looking for x. So what are we talking about here? What are we talking about? This 16 is the hypotenuse. This x is opposite from the 23. So I've got opposite and hypotenuse. That is the sine function, my friends. The sine function. So, okay, we will do sine of 23 is equal to opposite over hypotenuse. So that's x over 16. Am I going to do that little swap maneuver? No, that only helps me when the variable is in the denominator. When the variable is in the numerator, you multiply. Multiply by the denominator. So I'm going to multiply by 16 on both sides. Okay, that way these 16s cancel out. Okay, so that's going to give me 16 sine 23. Just put that in your calculator. Alright, that's 6.3. Got to round up. Okay, so we just found AC. Alright, now we got to find BC. Alright, so I'll erase the AC because we already found that. I'm going to move my x to BC. Okay, and again I ask myself, is this opposite, adjacent, or hypotenuse? Well, from the 23, this is adjacent. Okay, so I've got adjacent is what I'm looking for, and I'm given the hypotenuse, adjacent and hypotenuse. So what's up with that? Yeah, you guessed it, that's all about the cosine function. Because cosine of an angle is adjacent over hypotenuse, so that is x over 16. Once again, when the variable is in the numerator, you should just multiply by the denominator on both sides, because these will cancel out. Alright, so that's just going to give you 16 cosine 23. So that's 14.7. Okay, so that's BC that we just found. Alright, so that was problem number 1, part C. Okay, and that is the end of page 1. So that's probably a good time to stop this video. Alright, we'll pick up the next video with page 2 and problem number 2. See you on the next video, my friends.